right, let's get that set up there. Okie doke. So when we were covering the first part of the linear versus nonlinear lab, looking at slope and such, we didn't get all the way through the notes. So I'd ask you to kind of just like make a little note or a mark somewhere that indicated where we had gotten to. The tables. All right, good deal. The table, like right here? Okay. Did we get through them? Got to the second one. Okay, good deal. Good to know. Okay. So with these tables, again, kind of reviewing the first one, so they rely on the concept of substitution. All right, so you've got your x values on the left. It tells you here are your x values. Here is where x is in slope-intercept form. Let me swap this out real quick so it's a little bit bigger to see since we're just on this for the moment. Okay, so yeah, you just plug them in, do your order of operations, and then it'll give you your y value, and you make an ordered pair out of it. Now, a couple of things about number 2 here. First of all, how is number 2 different than number 1 apart from its y-intercept? Right, it doesn't have a variable in front of the x. Or in other words, there's nothing where the slope should be, right? So you got to think back. What did they tell you years ago when you see a variable by itself? What coefficient does it actually have? 1, right. And a good trick for that is, I know they get tired of me clearing my throat on the video. I was listening to my video from yesterday. I must have done it like 25 times. It's just smoke and pollen. But anyway, you know, like it? Sign up for in-person class. No, I'm just kidding. But a good way to remember that is how many of them do you see? 1. Let me just slap that in there. Now, for the function table purposes, it's not going to make a difference. You just plug it in, run the numbers, it works fine. But where you would need this is if it asks you a question of what is the slope of the equation y equals x minus 5? Well, if it's not shown, some folks may have some trouble with that. But if you know that there's an understood 1 there, then you can answer it. And if you're going to graph this, the slope would be 1 over 1 or just 1. Graphing 1 over 1 for the formula, it would just be 1. But years ago, somebody said that that is not simplified enough. Take the 1 out. If there's 1 variable there, they should know that. I'm assuming. So yeah, function tables, x goes in, y comes out, it makes your ordered pairs, and you're good to go. One of these days I would just like to have one class where I don't just put a random ink swarp where I'm trying to scroll. All right, graphing using points versus graphing using the equation. All right, so we've got the same equation here for both of these, okay? Y equals 2x plus 4, for both of them. All right, now this is the function from the first table, okay? So you've got 3 ordered pairs from that table, -2, 0, 0, 4, and 1, 6. So make yourself just a little, rudimentary coordinate plane, and then, when you make a coordinate plane by hand, try your best to do even-spaced tick marks. It's hard to do, so sometimes you just kind of have to fudge it. -2, 0, 0, 4, 1, 6. So once you've got those 3 points marked, draw your line through there. They look better when you use some sort of straight edge. But, I know we don't always have access to it. So, using the points. Once you find them, put it on there. There you go. The hardest part about that one is finding the points because you have to make a function table. Okay? Now, told you all that to tell you this. If you know what the linear equation is, you don't need the points. You can look at the equation and then just go ahead and graph it the way it is. So the first thing that you always put on a graph is the y-intercept, right? You always put that first on a graph. So there is positive 4 on our graph. So once you've marked the y-intercept, then you walk the slope to the next part, okay? And by walk the slope, what we mean is, here's our slope of 2 right here. We know that if it's a whole number, when you're graphing it, it works better as a fraction, right? So slope likes to be a fraction when you're graphing it. So you follow that slope to the next point, because slope is a set of directions. It's your vertical directions over your horizontal directions. So if it says something like 2 over 1, what that means is 2 up and 1 right between every point. 2 up, 1 right between every point. So to find the next point, I'm going to go 1, 2 up, and then 1 to the right. There's the second point on there, and then there you go. Easy peasy. The problem is, with this one, it's a lot more abstract than using the points, which is the concrete method. All right? You know, they call it concrete because you can like, oh, I see 3 points. I can draw a line through those, right? There are 3 points that I made. Whereas just using the equation is like, oh, okay, I see a plus 4 at the end. I know that that's where I'm supposed to start. I'm going to mark that. And then I'm going to work backwards and use the slope to find the next point. So if you want to think of it this way, this would be like, you know, beginner and advanced. I like to try to put things in video game terms whenever I can. Take the stigma off of video games, if you will. I know in the 90s they got a bad rap. All right, any questions about graphing using points versus graphing using the equation? Any questions at all? All right, let's push on then. Let's flip this on its head. Let's say instead of making a graph, you're just going to have to read one. So, graphs. Okay? So you got a pre-made graph, and they say, I want the equation off of that graph. You know exactly what you have to do. The same steps still apply. So the first thing that you do is you still find your y-intercept. Okay? So we know that it is positive 4, right? So 0, 4, or 0, positive 4. So there's our y-intercept right there. Okay? Then walk the slope to find the next point on that line. Now sometimes walking the slope to find the next point, it might not be a point that's actually on there. By point, they mean literally anywhere on that line, because that line is made up of a multitude of points. If they put this on a grid, where you're looking for is where the line crosses intersections of boxes or corners of boxes, because that means that both of the ordered pairs will be a whole number. All right? So let's find this next point here. You go down 1, down 2. So there's down 2. We went right 1, right 2 to get this next point. So there's that. Now, when you go down 2, that means negative 2, right? When you go down 2, that means negative. Down 2, negative 2. Right 2, positive 2. So you got negative 2 over positive 2. Well, that just means that your whole thing's negative, right? Negative 2 over 2 reduces to negative 1 over 1. Or just, I don't know why I need to fix this. It says 1. It should say -1. My bad. I'll fix it and re-upload it. All right, so it should be -1 over 1 or just -1. All right, I'll fix it and re-upload it later today. Bad thing about slope, when you start throwing negatives in there, like I told y'all on Monday, they are so easy to lose. It's like the backs to my daughter's earrings. One of these days, whenever we get rid of her bed, when we pick that thing up, it's just going to rattle and all the backs of her earrings are just going to fall out. Like, oh, that's where they went. So now that you've got their slope of -1, you can build the rest of the equation. To build the equation, you need two things. You need your slope and you need your y-intercept. Remember, with your y-intercept, it's the first thing that you look for on a graph. It's the last thing that you put in on the equation. So y equals plus or minus b. Sorry, y equals mx plus or minus b. So the -1 goes in for the m. Then the x stays the same. And then plus 4 goes in for the plus or minus b. To simplify it, we make it say y equals -x plus 4. Any questions about that one? Now all I can think about is that -1 that I messed up. And you know what's bad? It was like that in the spring, and I didn't catch it. Until now. Because I can't read. No, what it is my own pride. It's like, oh, you know, I wrote it down. It must be fine. No. All right, is anybody still copying this down? Everybody good? Ready to go to the next page? Okay. Finding slope from 2 points, or in other words, using the slope formula. Okay, so again, the slope formula, m equals y2 minus y1 over x2 minus x1. When you're finding slope, really, anytime you're using a formula, write it down. Even if you know it, write it down, even just as a reference, so you can see where everything went. All right, so our first, say what? Yeah, formula. Not everything translates in a copy machine. I could have said that the copy machine erased the negative off of that last problem that I messed up. And some people would have been like, oh. Yeah, exactly. No, I forgot it. All right, so number 4, we've got 0, 5, and 6, -3 as our 2 points. Remember, God almighty, I don't know what is going on with me. When you are finding slope, it helps to label your 4 parts. x1, y1 for the first order pair, x2, y2 for the second order pair. So when you put them in the formula, it's easier to get it aligned. So y2 is -3, so that's going to go in first. Minus 5, so that's going to go in there. Over x2 minus x1, which is 6 minus 0. Now, we talked about some ways that people mess these up. Of course, the most obvious and easiest thing to do is lose a negative or put one where there's not supposed to be one. Doing this upside down, I've seen that. People doing the x's above the y's. One that doesn't show up as much, but I thought of it this morning while I was out at Andrews, so I wanted to make sure that you saw it, is maybe the top is in the right order, but the bottom isn't. It's like maybe they wrote -3 minus 5 over 0 minus 6. That'll mess it up. Okay? Remember your 4 operations: add, subtract, multiply, divide. Okay? The reason why everybody likes adding and multiplying better than subtracting and dividing is because with adding and multiplying, it does not matter one bit what order you have them in, unless it's like an order of operations problem. But if you're just adding or you're just multiplying, it's basically just like throwing everything into a blender or an oven, and everything's going to come out the same anyway, right? Whereas subtracting and dividing, if you don't do it in the right order, it's going to mess it up. So that's why we got to be careful. But anyway, back to this. So negative 3 minus 5 over 6 minus 0 makes negative 8 over 6, which will reduce to negative 4/3. Always reduce your fractions with slope, because that means if you reduce it, that's a smaller distance you have to follow. Better chance it's going to fit on the graph space they give you. All right. Number 5. 2, negative 3, and 4, 1. So when you substitute those in, the top's going to say 1 minus negative 3. Leave it like that for a second, okay? Don't try to fix it too soon. You might lose a negative. The bottom will say 4 minus 2. So now on the next part, you can fix the minus negative to a plus, and you got 1 plus 3 over 4 minus 2. That'll make 4 over 2, which goes to 2 over 1 or 2. And remember, it depends on the situation what type of form you would leave it in. If you're graphing it, like if you're finding it to graph it, I would leave it as a fraction. Or if you read a graph that said find the slope of this graph, leave it as a fraction. But if you're putting it into an equation, you'll want to simplify it down to just 2. Okay? Make sense? Any questions on that? Anybody need a minute? Because we're about to get to the awfulness that is point slope form. It's really not that bad of a formula. It's actually fairly easy to use. Me as a person, I despise tediousness, things that take a long time to do. And point slope form takes a long time to do, so I kind of hate it. I'd honestly rather do like the sales tax or discount formulas, because they're a little bit quicker. But that's just me. All right, again, another reminder, if you're graphing, use the fraction. If you're building an equation, remove the 1. Another reason why some of this might look pretty bad is because I keep having to update this and fix things on it. So some of these pages are a copy of a copy, and you know how that goes, right? Point slope form. All right. This is the big boss of our slope game that we're playing. I'm really not trying to scare you. It's just, it's a little weird. Point slope form is the formula excuse me, the formula used for finding y-intercept. You use this when they have given you either 1 point and a slope, 1 point and the slope, or 2 points, and they say, make me a line. Like, well, there's a very important part of the line missing, which is the y-intercept. Well, luckily, the point slope form, that's its main purpose. Because what it does is it takes the information that you give it and then chop it down into a slope-intercept form equation. Y equals mx plus or minus b. Okay, to get point slope form to work, you must have 1 point from the line, at least 1 point from the line, and the slope. You've got to have the slope. It's non-negotiable. You have to have the slope for point slope form to work. It's in the name. Equations can be left in this form, but it works best when used to make slope-intercept form. Some worksheets and books, they say, take this and put this information into point slope form to make the equation of the line in point slope form, which is fine, except for one problem. If it's in point slope form, you can't really graph it, which is why we mostly, want things in slope-intercept form. So that's what point slope form does, is it makes it for us. Here's the formula for point slope form. Oh no, I've gone too far. So there's the formula for point slope form. Y minus Y1 is equal to m times x minus x1. Y minus y1 is equal to m times x minus x1. Okay? Now, I know that the point slope form calls for using x1 and y1. Technically, if both of the points sit on the same line, you can use either one of them in this, right? Because they'd both have the same linear equation. But in an effort to reduce confusion, whatever it says x1 and y1 are, we'll just use them and we'll just deal with it. All right? So let me get this switched because we're going to put some of these on the board. All right. So, I think this was part 5 in the notes or something. I don't really know where it was on ours. So point slope form. The formula for that is y minus y1 equals m times x minus x1. All right. So the first part of this that we're going to look at is point slope form involving one point and the slope. All right? So point slope with one point and the slope. Okie doke. So here's our first example. We'll call this number 1. You have a point of 2, 7, and you have a slope of -4. All right? So when the slope is provided for you, you can go ahead and jump right into point slope form. All right? So this will have, let's do this way. Y minus y1 equals m times x minus x1. And then it still helps if you label your x1s and y1s and x2s and y2s if they're there. All right? So we've got y minus 7 is equal to -4 times x minus 2. Okay? Everything has now been substituted in. Okay? Now when you get to this part, this is where you're going to lean back on something that you've probably not used in quite some time, which is the distributive property. Okay? Remember the distributive property? You've got a number on the outside of 2 other numbers in parentheses, and the 2 numbers in the parentheses are separated by a plus or minus. And you have to take the number on the outside and multiply it by both of those numbers on the inside before you add them or subtract them. Same idea here. We're just going to call them terms because not everything in this one is going to be a number. Sometimes it's going to be a variable. All right? So we've got y minus 7 on the left still. We're going to take this -4 and distribute it to the x and the 2. And we're going to leave that minus in there for now so we don't lose it. So -4x comes from -4 times x. Bring down your minus so that you don't lose it. What's -4 times 2? It's the simple ones that always get us when we're thinking about the complicated ones. -8. Very good. So -8 goes there. All right. Next step, we have a minus negative in the middle of that stuff on the right. We can't leave it like that. Right, turns into a plus because those are opposites. So -4x plus 8. Okay? To finish this off, the last thing that you always do on these is take care of the stuff that's happening to the y by zeroing it out. So if it says minus 7, you add 7. So y equals negative 4x plus 15. Okay. All right. Any questions about that one? These work best when you take your time with them. If you don't, you'll lose a negative. I did that a couple of times when I was making these notes yesterday. So it's something to watch out for. All right, number 2. 2, we've got negative 8, 2, and a slope of negative 3/4. Ew. Not only is it negative again, it's a nasty, nasty fraction. Well, a lot of people don't like fractions, so yeah. It's a nasty, nasty fraction. All right, so y minus y1 equals m times x minus x1. Again, the only reason why I have that memorized is because every time I do one of these problems, I write it down. Okay? I mean, that's the only reason. Like I went home after work one day, said it 100 times so I would memorize it over time. All right, so here is x1, here is y1. So let's get those put in. So I did it again. Y minus 2 is equal to negative 3/4 times x minus negative 8. All right. Now, that says minus negative. I think if you change that here, you'll still be okay and you'll wind up with the signage that you need. But I'm going to err on the side of caution, and I'm not going to change that until I've distributed. So take the negative 3/4 across both of those terms. Okay, so we've got y minus 2 is equal to negative 3/4 x. I'm going to go ahead and bring that minus down for now. And then who needs a scientific calculator since we've got fractions flying about? There we go. All right, everybody got their calculator ready? So what we're going to do is just multiply negative 3/4 times negative 8. Now, I know that we don't need a calculator for that, but it goes a lot quicker if you have one. What'd y'all get? Oh, it's not. Yeah, it is negative 8. Okay, yeah. Sorry, my brain is mush today. So negative 3/4 times negative 8 should give you a what? Positive. The button you're looking for fraction is the A, B, C. It's two or 3 buttons above 7 on here. Yep. So to do that, you would hit negative 3, ABC 4 times negative 8. Positive 6. Very, very good. Yeah. Now, like I said, I could have done that by hand, right? Negative 3 times negative 8, that's positive 24. 24 divided by 4 is 6. I did that faster than Alex put it in his calculator. It's fine. I'm just giving you a hard time. All right, so now y equals negative 3/4 x minus 6. We're going to add 2 to this other side to get it off of that y. So what is negative 6 plus 2? Negative 4. So the final equation for this is y equals negative 3/4 x minus 4. Alrighty. Again, that is when you have one point and one slope provided to you. All right. Now on Monday, I mentioned that the worst of these that you're going to see are when they did not give you the slope. All right, so we need to do 2 of those now. Who is still copying these 2 problems down or needs to get a picture of them for your notes? Everybody good? You okay? All right, so point slope form with 2 points and no slope given. This is the equivalent of making biscuits from scratch. I've always called it that. All right, so let's look at this number 3. All right, you've got negative 2, 6, and 3, 9. Point slope form does not work without the what? Slope. So if the slope is not provided, we have to find it. In order to find it, we use the slope formula. Remember when I told you what makes these so bad is that it's formulas within formulas within formulas? We're seeing that now, where you're going to use the slope formula to find the slope, to put into point slope form to get slope intercept. It's just jumping through hoops, unfortunately. Okay, so step 1, find slope. I don't know what I was writing. Find slope. All right. So you're going to use the slope formula. M equals y2 minus y1 over x2 minus x1. Label your ordered pairs to help you out. Okay. So, y2 minus y1, what's the top going to say? What's y2? 9. What's y1? 6. So top's going to say 9 minus 6. Good. The bottom, what's x2? 3. Good. Minus, what is x1? Negative 2. Very good. All right. So now you can start chipping away at this. 9 minus 6, well, that's easy. 3 minus negative 2, let's clean that up. 3 minus negative 2 makes 3 plus 2, right? So 3 over, what's 3 plus 2? 5. So 3 over 5. there is your slope. Okay? Now, the slope is used for part 2, which is where you bring in point slope form. Okay? So now, write that down. Y minus y1 equals m times x minus x1. Okay? So, x1 and y1, that's negative 2, 6, right? So, y minus 6 equals 3/5 times x minus negative 2. Just substitute that stuff in there. Okay? All right. I know that we've got an x minus negative 2 in that parentheses. Let's hold off on that just yet. We'll need our scientific calculators again, because we're going to distribute the 3/5 across the x and the negative 2. So the left will remain the same. The left will say y minus 6. 3/5 x. Bring down your minus. All right. Who's got the quick draw on the scientific calculator? What's 3/5 times negative 2? And I don't want the mixed number. Remember, in slope we don't like those. Is it 6/5 or is it negative 6/5? I'm going to take pieces of both your answers and put it together. Yeah, negative 6/5. Now, if when you're dealing with fractions in a scientific calculator, it gives you, the scientific calculator goes to a mixed number by default. So, like, let's go back just a second. So it was 3ABC5 times negative 2, and it pops up as negative 1 1/5, right? By default. If you hit second ABC, enter, voila. Makes it improper for you. In blue, or whatever color your calculator is, in your alternate color above the ABC button, that is your mixed number and fraction interchange. So whatever form you need, if it's not giving it to you, second, hit that button, it'll switch it around for you. All right? Pretty handy. All right, we're not done with the graphing calculator. Yeah, we're done with those. The scientific calculator, we're not done with that just yet. All right? One last thing we need it for. We had minus and negative, so we're going to fix that to a plus. Now, to finish this off, we've got to add 6 to 6/5 on that right side. So, go ahead and do that with your scientific calculator. 6/5, 6/5. I got something different. Let me double check it. 6ABC5 plus 6, and then second ABC. All right, what'd y'all get? Who got 36/5? Okay. Bunch of shy little mathematicians out there. Okay, good. Yeah. And you'll see that right there. Yeah. There it is in all its glory. Okay. So we found the slope, 3/5, and then we use the slope in point slope form to get the rest of the equation. Now, once we've got this set up in slope intercept form, which is what point slope eventually gets you to, now if you had to graph it, you could. Although hopefully, you're not going to be asked to graph anything in the neighborhood of 36/5. I mean, you could if you needed to, but it's just difficult. All right? I think we got time for one more. Anybody still copying that one down? Or need to get a picture of it? It is in the provided notes if you just want to get it from there. Okay? All right. Last one. We'll see if this one goes a little faster. All right. Okay. We've got, oh. No. The last page didn't upload. Why? Because of course it didn't. God. It has been one of those days. All right, well, we won't do the next example then. Because it's on a notebook in my office, and that's all the way over there, so I'm not going to worry about it. Okay, a couple things to remind you guys about, though, while I've got you for a few minutes. So, your Probability and Stats Lab 3 closed yesterday. All right, I have not graded the work for that yet. I'm going to try to get to that tomorrow, hopefully before 12 when the campus closes. All right, if you did not know that, tomorrow the campus is closing at 12 for Veterans Day. So any class you have after 12 tomorrow, if it's on campus, check with your instructor to see what they are going to do. All right. Also, open currently is the Probability and Statistics test. All right. That is due on the 14th. You've still got plenty of time to get that done. Okay? So just make sure that you do, in fact, get that done. Each part of it is worth 75 points apiece. So, you know, ideally, if you score a perfect score on everything, you could get 150 points. Some people desperately need that. Right? All right. And then one more thing to look at here with slope. Okay, these two pages here came out of this book. It is the Big Fat Middle School Math Workbook. It's the companion book to the one I've got in the syllabus that's called Everything You Need to Know to Ace Math in One Big Fat Notebook. This is a little bit more concise. The other book had slope spread across several pages. This kind of chops it down into a quick little study guide. So, again, slope, the ratio of your vertical change over your horizontal change. Now, one thing that we haven't really talked about much, 4 types of slope. Okay, here, let me get this on the big screen for the video. There we go, yeah. You got a positive slope, we talked about that, right? Going up to the right. We have a negative slope. We talked about that. Going down to the left, right? Positive and negative for slope is the same as positive and negative for a scatter plot. What we did not talk about undefined slopes and zero slopes. Okay? We did say with scatter plots that if it's straight up and down or a straight horizontal, you would call that a no correlation or a no relationship, right? Because what that means is one of the variables is going to do whatever it wants to do, and the other one is having absolutely no effect on it. That's what's happening here. Okay, with an undefined slope, what happens is this one, undefined, is when you have something like 5 over 0 after you do your slope formula. You've got a 0 in the bottom. Mathematically, you can't divide by 0. That's what they used to call an impossibility. Because if you divide, if you divide by nothing, did you divide? Makes you think, right? So in that instance, you would say it's undefined. If you tried to do it in your calculator, it would pop up with like a syntax error or something. Whereas zero slope is the opposite. Zero slope is when the 0 is in the top. Okay? When the 0 is in the top, you're wise. 0 divided by something, that you can do. 0 divided by whatever is still just going to be 0. If you have nothing and cut it into 5 pieces, you still have nothing, right? So that makes a flat horizontal line. All right? Now, There were questions about this stuff on the lab. I took them off, replaced them with point slope. Okay? Just because that's more important. All right. Again, it kind of walks you back through the two ways to get the slope. So this book called Walking the Slope, using something called a slope triangle. So it's like saying, all right, here's your line. Okay. And then when you walk it, all right, it makes a right triangle when you're trying to get to the second point. So if your rise is -4, you're going to drop down 4, and your run is 5, you're going to move over 5 to the next point, and you can see how it kind of makes a right triangle that way, right? The other way is also just using the slope formula, okay? So take, this is 2 different points. So take those 2 points, run it through the slope formula, and voila, slope spits out, okay? So it just kind of walks you back through that, okay? So just another little helpful diagram. What has happened? I don't know. Okay, time for y'all to skedaddle. Again, the assignment for the Linear Lab 1 will not open until Monday. Okay? It will, however, be open while the test is still active. Please don't do the Linear Labs until you complete the test. Okay? Don't confuse yourself. On Monday when we come in, we'll look some more at point slope form, and then we'll also look at some of the questions. Yeah, if you got one of my calculators, put them back, please. Appreciate it. And then you're free to go. See ya.